everyone, we're going to work on these two problems here and basically just discuss what essential discontinuity is your vertical asymptotes, and a removable discontinuity just means you have a hole. So it's like a point in the graph. So we'll get started on these and talk about the discontinuities. So the first thing we're going to do with this is factor it. When you factor this, you get 2x plus 3 and x minus 5 divided by x plus 4 and x minus 5. So the first we have a removable discontinuity, also known as a hole in the graph. It happens here. So it's going to be if x minus 5 equals 0, it occurs when x is 5. So to get the other y coordinate, you just plug it back into your reduced equation. Let's call this the reduced equation. And when you plug that in, you're going to get, let's see, 13 divided by 9. All right. Your essential discontinuity is your vertical asymptote. So when you have y equals 2x plus 3 divided by x plus 4, we can't divide by 0. So if x were negative 4, that would mean this would be 0, and that's impossible in math, so it'd be undefined. So x cannot be negative 4. That means we have a vertical asymptote at x equals negative 4, and that's called your essential discontinuity. So I went ahead and took the liberty of kind of graphing this. This is where it's discontinuous right here. The graph goes up in here, but there's a vertical asymptote here at the essential discontinuity, so it jumps over here. So it's not continuous. And then for this portion, I went ahead and graphed the hole here. There's a hole in the graph where we took out the common factors. And so this point here would be 5, 13 divided by 9. So that's the difference between the two. So let's do one more. The first thing we're going to do is factor this. So we will get x minus 3 times x plus 8. That gives you the top portion. And the denominator is going to be x minus 3 times x plus 2. So the same thing kind of happens with this one. We're going to have a removable discontinuity here at 3. So that's where x is 3. So plug it back in. So 3 plus 8 is 11 divided by 3 plus 2 is 5. So this is a little bigger than 2. So it's a little bigger than 2. Now, also on our reduced equation here, y equals x plus 8 divided by x minus 3. X cannot be 3 because if you plug in 3 here, you'll be dividing by 0, which you can't do. So we have a vertical asymptote at x equals 3, which means that's your essential discontinuity. And I think I graphed this here. So basically, your hole occurred at 3, 11, what was it? Yeah, 11 over 5. So I should have made it a little bit higher here. But there's a hole here. Your essential discontinuity is here. So the graph is not continuous. It jumps over because it can't cross the vertical asymptote. And that's it. Thank you. Have a nice day. Bye-bye.
Class, Miss Shaw's class. Boy, I love math. Miss Shaw's class, Miss Shaw's class.
Don't fail. Watch Miss Shaw's videos for free.